Isotopes. One of Dalton's postulates in his atomic theory was that all atoms of the same element are exactly the same. That's not quite true. They all have the same number of protons, but their masses vary slightly, and that's because they can have different numbers of neutrons. Neutrons are massive particles in the nucleus of an atom, but they have no charge. So you could add a neutron or two, and it's not going to affect the charge, but it'll change the mass a little bit. And so the word isotope refers to atoms that have the same number of protons, but different numbers of neutrons. Some elements have only one isotope. Some elements have 3 or 4 isotopes. You can't predict that from the periodic table. You're not expected to know which of them do or don't. And all elements have their own unique percent natural abundance of isotopes. If an element has 2 isotopes, that does not mean that half of the atoms of that element are one and half are the other. It varies, and we figure that out by experimentation. Here's an example of neon. So neon has 3 different isotopes. We call them neon 21, neon 22, and neon 20. Neon 20 is the most common. 90.48% of all neon atoms are this isotope. 9.25% are neon 22, and only 0.27% are neon 21. The differences between these 3 isotopes is the number of neutrons. We have multiple ways of indicating particular isotopes. One way is sometimes called a nuclear symbol, and so we use the chemical symbol for that element. Here we're representing it with X because there is no element X on the periodic table. And we've got the mass number up here and the atomic number down there. We didn't define mass number yet. Oh, it's coming on the next page. So the mass number is on the top and the atomic number is on the bottom. What does the atomic number represent? Number of protons. Okay. The mass number, as we'll see in a minute, is the number of protons plus neutrons. The number of particles that have significant mass. The electrons are so small we don't even bother. So for those 3 different isotopes of neon, here's neon 20, neon 21, and neon 22. They all have the same number of protons. They all have the same element symbol. They're all neon. But they have different numbers of neutrons. And you can tell how many neutrons by just doing a little subtraction here. 20 minus 10, this one has 10 neutrons. 21 minus 10, this one has 11 neutrons. And 22 minus 10, this one has 12 neutrons. So a difference of neutrons. Same protons, same element, slightly different atoms. So the mass number is A. Again, don't ask me why. It's the number of protons plus the number of neutrons. So like I just showed you, if you need to know the number of neutrons, you just subtract them. Another way of notating different isotopes is using the chemical symbol or the chemical name and a dash followed by the mass number. So those 3 isotopes of neon, Ne20 or neon 20, we don't really need the atomic number, right? Because if we wanted to know the atomic number, how many protons, we could look at the periodic table. And we could figure that out. We don't actually have to have it written down. It's the mass number that's important. So neon 21, neon 22. So this is the mass number, the total number of protons and neutrons together. So we need to be able to do things like this. What are the atomic number, the mass number, and symbols for the chlorine isotope with 18 neutrons? So chlorine, what's the symbol for chlorine? Cl. And we're told it has 18 neutrons. How many protons does chlorine have? 17. So then what's the mass number? 35. Total of 35 protons and neutrons. So we can do it like this with the mass number up there and the atomic number down here. That's one symbol. This equals the mass number, which the question asked for. This is the atomic number. Question asked for that too. And then the symbols. So this is one symbol. We can also identify it as Cl dash with the mass number, or the whole element name, chlorine 35. Any questions? What if they give us the symbol? How many protons and neutrons are in this potassium isotope? Well, what's this number on the bottom? That's the atomic number. That tells us the number of protons. Well, let's actually move that over a little bit. So 19 protons. You could also look on the periodic table and find potassium, and it's 19. How do we figure out the number of neutrons? Subtract. It's all stacked up for you to subtract. Isn't that nice? Look at that. So there's 19 protons and 20 neutrons. How else could we indicate this isotope? K dash what? 39. Or potassium 39. Any questions?